Now we'll study about transformer. About transformer we can write that it is a device used to increase or decrease AC voltage by using the concept of mutual induction. In mutual induction, we already studied that when a time varying current flows through a coil, due to the linkage of flux between the two coils, an EMF is induced in the second coil. This is the phenomena which we call mutual induction. Using the same phenomena, we are going to study about the device which we call transformer. Let's have a look on a schematic diagram and the device which we call transformer here. This is the diagram of a transformer in which there exists a soft iron core on which on one side a coil is wound which is connected to an alternating EMF source which here we are representing as E1 as a function of time, due to which a current flows through it. And if a current flows through the coil, magnetic flux is produced, and due to the soft iron core, the flux is guided throughout the core, and the same flux will pass through the other coil which is connected on one side, another side of the soft iron core. Now this coil we call primary coil of the transformer, or it is also termed as P coil, and this is the secondary coil of the transformer, which is also termed as S coil. Primary coil is the one in which an AC EMF is connected, due to which a time varying current flows, and a magnetic flux, here you can say flux phi as a function of time, is produced. As current varies with time, the magnetic flux also varies with time. The flux will pass through the other coil, and you can see if the magnetic flux passing through the other coil is changing. Here we can see an EMF is induced in it, which we can write as E2t, due to which a current I2t flows through it. This is also time varying, that's why we are calling these E2t and I2t. Now in this situation, due to this I2t, again the flux varies, and finally say we denote the flux phi, which is as a function of time due to both of these currents. So here we can see if N1 are the number of turns in the primary coil and N2 are the number of turns in the secondary coil, then here we can directly write E1t, which is the terminal potential difference of the primary coil. Its total potential difference will always be equal to the rate of change of flux, which is linked with this. So here we can write E1t is always equals to d phi 1 by dt, where phi 1 is the magnetic flux linked with the first coil, as these two are always in parallel. So phi 1 we can directly write as N1 phi, if phi is the magnetic flux which is passing through the soft iron core or any cross section of the soft iron core. So this can be written as N1 multiplied by d phi by dt. So this is our equation 1. Similarly, here we can write E2t, which is the EMF across the secondary coil or S coil of the transformer. We can write as d phi 2 by dt, where phi 2 is the flux linked with the secondary coil, and here phi 2 we can write as N2 phi. So here it can be written as N2 d phi by dt, and say this is our equation 2. And here you can see if we divide the two equation 1 by 2, see what it will result. This will give us E1 by E2 is equals to N1 by N2, as d phi by dt is the common term in the two. And this equation, which relates the EMF induced across the terminals of primary coil and secondary coil ratio, is equal to the ratio of number of turns of the two coils. This equation we call transformer equation of a specific transformer. So you must be careful in any case whenever we are required to relate the potential differences across the two coils. It can always be considered in the same ratio of the number of turns.